Hello everyone, it's Melker John. Today I am going to read S6 1693 Future Energy by Alex Rainham. Chapter 7 The Bright Future. The sunlight that reaches Earth in 1 hour has as much energy as much as all the power that people use in a year. But how can we get this energy and use it on Earth? Solar means coming from the sun. So when you use sunlight to make things hot, it is called a solar thermal power. Many buildings use materials like glass and plastic to catch sunlight and heat the building. In Africa, people use solar cookers. When light hits the surface of the cooker, it is reflected into the middle. The middle becomes hot enough to heat water or cook food. In countries like Turkey and China, people put solar water heaters on their roofs. These are metal and glass boxes with water pipes in them. The glass catches heat and the metal reflects sunlight onto the water pipes, which carry the hot water down into the house. We can use sunlight to make electricity too, which device is called the solar cells, which are made of silicon. When sunlight hits the silicon, particles inside it move, and this makes electricity. A solar cell does not produce much power, so we put the cells together to make big solar panels. At the moment, the best solar cells can only use about 25% of the sunlight that hits them. And they are an expensive way to produce electricity, but people are inventing better and cheaper solar cells all the time. In the future, we'll use it to do more and more things. You can already buy solar lights, solar radio, and small solar panels. For things like computers and phones, we can use solar power to travel too. In July 2010, Andrei de Borshchev flew a solar plane called the Solar Impulse for 26 hours before he stopped. Power for the force for engines came from 12,000 solar cells on the wings of the plane. It was able to fly at night because of batteries inside the plane, which kept solar energy. There are also solar boats, and every 2 years in the World Solar Challenge, solar cars leave Darwin on a 3,000-kilometer journey across Australia. They all try to be the first to arrive in Adelaide, and the fastest cars can reach 100 kilometers per hour. In sunny countries like Spain, China, and the USA, they are building huge solar power stations. Some use solar panels and others use devices called reflectors to reflect sunlight onto water pipes or tall towers. The Andasol Power Station in Spain is as big as 70 football fields. It produces enough energy for 200,000 homes. Imagine standing in the Sahara Desert in 50 years' time. The bright sun hurts your eyes and the heat is fantastic. All around you can see tall towers and thousands of solar reflectors. It is only a dream at the moment, but many people want to build hundreds of solar power stations in the Sahara Desert, where it is hot and sunny for 365 days a year. Just 0.3% of the Sahara Desert gets enough sunlight to produce electricity for all the people in Europe. Chapter 8 When the Wind Blows. On a clear day, you can see them from the land. They look like huge metal flowers growing out of the sea. When you get closer, you realize how big they are. The Thanet wind farm is 12 kilometers off the English coast. Each of its 100 turbines is 150 meters tall. As wind turns the turbine, generators inside them produce electricity. Together, the turbines make enough power for 200,000 homes. There are 250 wind power stations called wind farms in Britain, and people are building more every year. By 2020, Britain may get 25% of all its energy from the wind. The Bahrain is famous for the strong winds that blow at different times of the year. The World Trade Center in Bahrain is a skyscraper with 3 wind turbines. The turbines are 29 meters across, and and they produce about 15% of the electricity for the building. That is enough energy for 300 homes. The shape of the building moves the wind towards the turbine. It was very difficult to build the Bahrain World Trade Center because it was the first building of its type in the world. Engineers had to stop the moving turbines, shaking the building and destroying it. Now skyscrapers with huge wind turbines are appearing in cities around the world. Some future skyscrapers will not use turbine. The buildings will turn in the wind. As the parts of the building move, generators between the floors will produce power. Because the wind will move faster at the top and slower at the bottom of the building, each floor will turn in a different way. What you can see from your window will change all the time. Lots of city buildings now have small wind turbines on the roof. You can even buy one to power your house. Wind turbines used to be ugly, but now there are lots of different shapes and colors, and they are great for parks and city centers. Soon tourists will see a wind turbine with changed color pictures outside the Buckingham Palace in London, for example. Of course, wind turbines do not work when the wind is not blowing, but people are finding new ways to catch or produce enough wind. When it is not very windy on the ground, look at the sky, and you will often see the clouds moving fast above you. The bars will, when turbines fly a few hundred meters above the ground, their shape makes them turn in the wind and produces electricity. Long cables tie them to the ground and carry the electricity. Another idea is to use wind turbines next to busy roads. As cars go past, they move a lot of air. This drives the turbine. In Jinshaowan, China, a tall tower stands in a field of glass. The sun hits the air under the glass. The hot air moves up the tower, and wind turbines inside the tower make electricity. In the future, people are planning to build towers like this in places like Australia and the USA. Some of them will be higher than the tallest skyscrapers in the world. We have used the wind to sail for thousands of years, but the engines of today's big ships use diesel fuel, which comes from oil. However, some new passenger ships have both engines and sails. The sails on these modern ships are moved by computer, so they can move and catch the wind, saving the ship a lot of fuel. Sky sails are another great idea because you can use them with any ship, even old ones. They fly about 200 meters above the ship and help to pull it through the water. How about sailing to work in a car that uses the power of the wind? The Green Bird looks like a plane or a boat, but it moves on land. Sometimes it can reach 200 kilometers an hour. The Green Bird uses clever technology to move 5 times faster than the wind. The Netherlands is a country of windmills. Old buildings with sails that turn in the wind. The country's 1,200 windmills are hundreds of years old. They are used for lots of things, like moving water and making machines work. Now, wind turbines that make electricity are appearing all over the Netherlands. For the people of the Netherlands, wind power is better, both the past and the future. Chapter 9, Water World. I'm standing by the Ceyhan River in Turkey, watching fish swimming in the water. How many rivers like this are there in the world? Think of all that water running down towards the sea. Moving water has much more energy than the wind, and of course, it never stops. Hydroelectric power. Hydroelectric power station uses the power of water to produce electricity. The Itaipu Dam between Brazil and Paraguay is one of the largest hydroelectric power stations in the world. It took 40,000 workers 9 years to build it, and engineers had to move the Parana River, one of the greatest rivers on earth. The Itaipu Dam is as tall as a skyscraper. behind the dam, water is kept in a lake called reservoir. Water from the reservoir moves down through huge pipes in the dam. The water turns turbines, which turn generators to produce electricity. Itaipu Dam produces 90% of Paraguay's electricity, as well as enough power for 600 million people in Brazil. Dams can be good in many ways. In Egypt, there used to be terrible floods on the river Nile after heavy rain, but the Aswan Dam has stopped the floods. Water stays behind the dam in Lake Nasser, and farms can use this water when it is dry. In Turkey, 5 dams on the Euphrates River have changed the land around them. Farmers can grow much more food, and people from the cities spend the weekends enjoying the beautiful lakes. The biggest problem with dams is that their reservoirs cover a lot of land. Beautiful places and old buildings often disappear under the water, and people have to leave their home. After engineers built the Itaipu Dam, people in boats worked hard to save animals as the water flooded the forest. They also moved the thousands of trees and plants to higher places. At Abu Simbel in Egypt, people saved the 3,000-year-old Egyptian buildings from the waters of Lake Nasser. The huge buildings were cut into pieces, then built again in a higher place. The workers had to cut a lot of stone by hand, and some of the stones were 30 tons. You don't have to build a huge dam to get energy from rivers. A lot of people in Africa and Asia make hydroelectric power themselves. They put pipes and little turbines into rivers in places where the water is moving fast. This produces enough electricity for 1 or 2 houses, or sometimes a village. The smallest turbines only cost about $20. There are more than 100,000 of them in rivers in Vietnam. Of course, we do not have to get power only from rivers. 97% of the world's water is in the sea. Now we are beginning to use it. Power from the sea. In 2008, passengers in planes flying to Porto, Portugal, looked down and saw 3 strange shapes in the water a few kilometers from the beach at Agucadura. Each of these big red shapes was 142 meters long. In fact, this was the world's first wave found. And the strange shapes were wave power generators. In the future, we may see many more farms like these near the Portuguese coast, getting power from the restless waves of the Atlantic. When wave power generators go up and down on the water, liquids inside them move. The liquids then turbines or push other devices to generate power. Long cables under the sea carry the electricity to the land. The great thing about wave power is that you can get electricity 24 hours a day. Problem is that waves can be too big. Storms can destroy the machines or break the cables. Getting power from the waves is still very difficult, but people are developing new devices all the time. In May 2010, a ship pulled a 200-meter wave power generator through Atlantic waters to Orkney, north of Scotland. In a few years, 65 more machines will join it, and together they will produce power for about 30,000 homes. Building and using the generators will mean new jobs for hundreds of people in Scotland. Near New York City, 6 turbines sit at the bottom of the East River. They are 500 meters across. They look like wind turbines, but they get energy from seawater that moves past them twice a day. In places where rivers join the sea, the water can go up and down 10 meters or more, so it moves very fast and has a lot of energy. To use this energy, we can put turbines under the water or build dams. The world's biggest dam that uses the power of the sea is at La Rance in France. It is more than 300 meters long and its 24 turbines produce enough power for a city of more than 200,000 people. Near the coast of Bukona, Hawaii, the weather is sunny and the sea is very deep. The water is warm at the surface. About 1,000 meters below this, it is 10 to 20 degrees Celsius cooler. People use this temperature difference to make power. Power stations like the one at Keyhole Point in Hawaii use liquids like ammonia that become a gas at low temperatures. Warm seawater heats the liquid so they turn into gas. The gas moves turbines to generate electricity. Colder water from deep under the sea turns the gas back into a liquid so we can use it again. Many countries already get a lot of the energy from water. For example, Norway gets 99% of its electricity from hydroelectric power. We have used the hydroelectric power for years, but in the future, people will get more energy from the sea too. We're still learning how to do this, but there are lots of possibilities. After all, 70% of our planet is covered by water. The end.